Okay, the integration by parts is really easy actually to understand if we come back to the point that we do a derivative of two functions that are multiplication, right? If we have a multiplication of two different functions, the derivative of that multiplication of functions, it will be the derivative of the first one multiplied by the original function b plus the original function u multiplied by the derivative of the function b, right? Now what? Now if we just move the terms to one side to another, for example, this one we'll keep this one here, but we move this term that we have to the other place, we will have to subtract in both sides, so we'll see like this, and we will have this alone, right? So if we want to integrate this part alone, we will see that at least in this part, this is the derivative of the original function, so that the fundamental theorem of calculus, this will be directly the u multiplication by b, right? And we will only have to get the integral of the second part, right, of the equation in order to get this one. So this is the formula, the general formula for integration by parts. As an example, I have this one here, the logarithms. And this is, by the way, a definitive integral. This is basically the integral when we have streams that we want to include as a part of the results, right? So the first part is to understand which one will be u. In this case, I only have one function that is visible, is the logarithm of x, right? The other part, the derivative of b, okay, I don't see it, but I will say that this is 1 multiplied by the differentiable term, right? If I do the integration of u, I'm sorry, the derivative of u, I will have 1 over x multiplied by the x, right? If I take the integral of the x, I will have b as a x directly. So substituting in the function that we have it here, we will have that u is logarithm of x multiplied by what? By v, which is x, right? And we have to evaluate this between 3 and 2, right? Minus the integral of the derivative of u. The derivative of u is this one, is 1 over x, right? Multiplying and the differential term, right? Multiplied by b, which is x. This x will basically go away, right? And we will have just this part, which is the integral of the derivative of x, which is x, and we have to evaluate x in 3 and 2. And then that is what we do. We do the evaluation, we substitute the 3 everywhere here, minus 2 everywhere there, right? Minus 3. Okay, we have the minus here, so this is minus 3 plus 2. This is minus 2, but because it's minus, minus is plus, right? It's minus 2. Okay, and then if we do the arithmetic operation, this is the final solution. Another example that I have prepared for you guys is this. The cosine, the square, right? If we have to do the integral of this, okay, we have that u will be cosine, derivative of b will be also cosine of u, or of theta, like the differentiable of theta. The derivative of cosine is minus sine of theta, and the integral of cosine is the antiderivative, which is sine of theta, right? So if we do the substitution, these two terms come together, and then, oh my goodness, okay, this is a minus here, but because I have a negative sign, and negative sign we got positive sign, so we have this integral here, but we can still apply the trigonometric substitution, right? And because that we have 1, we have the negative of cosine square, right? Then this, which is basically the initial term that I have here, is equal to these two terms that we have here, plus what? Plus this one that we have here, which is this, right? Minus the cosine, the integral of the cosine square. Oh, but this is again the same thing that we have at the beginning. So we can move the whole term, because that is subtracting here, to be adding in the other side of the equality. Then we will have basically two of these terms are equal to this. Or we can write it in different way. What we want to have in the integral is the half of what we have at the beginning.